Hello, and once again welcome back to the YouTube channel. Today we're going to do something slightly different. We're not going to go through English, we're going to go through the chemistry study skills. So we're going to try and revise chemistry effectively. We're going to remember some key concepts and we're going to try and feel confident for our exams. I have a biology booklet and a physics booklet as well, and we're going to go through the chemistry one today. So this symbol here is going to be a confidence tip. So if you're feeling a little bit shaky with your chemistry and you don't really know what's going on, read your little tip and it will help boost your confidence. There's rating systems, so the topics that we cover in this booklet you can rate out of 5, just to help you categorize what you need to revise and what you don't necessarily need to revise. When you see this symbol here, you're going to write your targets and your goals for upcoming revision sessions, and anything in kind of a post-it note looking thing will be an activity to help you boost your skills. So our first thing is how to study chemistry effectively. First tip is writing equations. Equations, you can't learn them just from reading them. You need to use them in practice. You need to write them down. You need to use them properly. You're going to put them into written practice, not just memorize them from a textbook, because that won't be an effective way to really commit them to memory and be able to use them properly. You're also going to do some sequencing. So any processes that are related to chemistry, you're going to break them down into numbered steps and add a short explanation for why each step happens. Being able to explain why something happens just gets you that little bit closer to being able to understand it properly. You can use a flow diagram, you can use arrows, try and do something visual rather than writing it in paragraphs, because that will help you, again, memorize it properly. Learning your maths. Chemistry, GCSE and biology and physics, all the science, they are full to the brim of maths questions. So if you practice 5 to 10 per week, so related to whatever topics that you're revising, that will make sure that when they come up, you are guaranteed your marks. You want those maths questions to be those questions where you are guaranteed full marks every time. So to do that, all you need to do is practice. You're going to show your workings as well. You will get rewarded for clear workings out. I had a question in my, not my actual exam, but in my mocks in year 10, where I got the answer wrong, but because my workings were so clear, I got 5 out of 6 marks. So I only lost the 1 mark for getting the answer wrong, whereas if I hadn't shown my workings and laid them out as clearly as I did, I might not have got any marks. We're also going to learn our key terms. So similar to biology, the chemistry mark scheme is very specific. It's not as specific as the biology mark scheme, but it is very specific. So you will need to learn your key terms and you need to learn them with precision. If you learn them with precision, you will stand out. Your paper will stand out from the rest of the crowd of papers, and the examiners will love this. They will find it so refreshing and they will be more likely to mark you higher. You're also going to ask yourself why. Ask yourself why something happens. Being able to explain why something happens, again, as I said before up here, will just help you to be able to explain it in a stronger way. So why does the temperature affect particles? Why does the reaction happen? Learning why is so important. And then required practicals. You're going to treat every single practical as exam content. They are often misunderstood and not revised properly, and they come up on every single exam. So again, like the maths questions, you want them to be where you're going to get your easy guaranteed marks. So you've got to make sure they're one of your strong points. There will be more on that later. So why do key terms matter so much in chemistry? Chemistry mark schemes often require exact terms. If the keywords are missing, the mark is usually not awarded, even if your ideas are correct. They also show your scientific understanding. They're about explaining processes at a particle level, and using the correct terminology shows the examiners that you understand what is going on. Because that's all it is at the end of the day. They just want to know that you understand what's going on. Higher mark questions reward clear explanations using scientific language. Without your key terms, your explanation is going to sound super vague, the cause and effect will be unclear, and your marks will be capped. So using your accurate key terms will help you reach full marks, especially in those longer answer questions. And also, it has lots of ideas that are very, very similar that need to be distinguished. So endothermic versus exothermic is very similar, or concentrated versus dilute, or oxidation and reduction, those kinds of things, you need the key terms because the ideas are very, very similar. And if you use the wrong key term, the meaning of your answer is completely different to what you intended it to be. So what I want you to do now is choose 5 key terms from your current topic, and you want to write the definitions from memory. You're going to then check your accuracy and then rewrite anything that you missed. This shouldn't take you more than, I would say, 5 to 10 minutes. So you can pause the video and do it now, or you can just come back to it later. But just have a go at doing that. Whatever topic you're currently revising, doesn't matter what topic, I'll give you a couple seconds just to pause and screenshot or do whatever it is that you need to do. Okay, and now let's move on. How can we learn these key terms effectively? Because as we know, they're very important. So how can we learn them properly? First thing is, create a keyword checklist for each topic. So kind of like a word bank. Every time you study a topic, have on the back of your page, let's say you make a mind map of a topic, on the other side, write a word bank for all the keywords and what they mean, so that you know what everything means. You're going to tick off all the terms that you can confidently explain, and you're going to practice using them in your 6 markers. So what I mean by this is, every time you write a 6 marker, highlight all the key terms that you've used and see if you can add in any more. Also, learn your definitions word for word, so this is where your word bank will come in handy. So you write the term and the definition. Compare your definition directly to a mark scheme, and if your definition isn't 100% correct, make sure that you add in anything else that you need to add, because learning it word for word where needed can really help strengthen your use of the key terms. We're also going to learn terms in pairs or contrasts, create comparison tables and write one sentence explaining the difference. So again, this is like exothermic and endothermic. You're going to write how they're different, how they're similar. Use each term in a full sentence. We're not going to just litter it with terms on their own. You're going to try and use them in a full sentence so that you know what they kind of mean and where they fit in. Link the terms to processes or diagrams. So if you draw a diagram of a process, label it with all the key terms, and also ask yourself, where would this appear in an exam question? Remember, if you can define it clearly, you can usually explain it clearly. So let's do some practice here. So this is something, again, screenshot, and what you're going to do is you're going to look at this diagram, you're going to label it with as many key terms as you can related to electrolysis. Then you're going to use a textbook, find any key terms that you missed and add them in a different colour, and all the ones that you missed or got wrong, put onto flashcards and test yourself later. Check your spellings and accuracy, because this is very important. So I'll give you 1 second just to screenshot this. 3, 2, 1. We're going to move on. Repeat this with all your other topics, and also rate how you feel about using key terms. Command words, very common in physics, biology and chemistry. You're going to need to define, so you're just going to say what happens, no explanation. You're going to just tell us what that word means. Describe, again, no explanation. If it's in relation to a diagram, you're going to just say what you see. Don't want to tell us a reason why. Explain questions. Here's where you, when you're asking why this happens, this is where you add that in. You need a little bit more detail, so you describe it as you would have done in a describe question, and then you add, you just sit there for a second and you go, but why did this happen? And then you write that underneath. Compare. You'll be given 2 or more points or 2 or more pieces of information, and you'll be asked to identify similarities and differences. If you don't write about both, then you will not be given credit. You have to include both similarities and differences. Evaluate is very similar to compare, but you're going to add pros and cons, so you're going to include an opinion. You're going to avoid your I think statements, you're going to keep it objective. So if it said, for example, it would give you a couple of renewable energy resources and it would ask you to evaluate them, you're going to say some pros of each resource, some cons of each resource, and then overall which resource is better. And suggest is similar to describe or explain. It will give you a process and it will ask you to suggest an explanation or suggest some extra information about that process. Long answer questions, 5 or 6 marks. Lots of students struggle with these, but if you use this format in your biology ones, in your chemistry ones, in your physics ones, you are pretty much guaranteed 5 or 6 marks every single time. So, step 1, identify the focus of the question. What is the question asking you? What topic is it related to? Highlight your keyword terms and your command word, as well as any conditions in the question. So conditions, I mean temperature, pH, things like that. This will really help categorize what the question is actually about, because you can't answer a question if you don't know what the question is about. Then step 2, we're not going to write anything yet, we're going to plan what we're going to write. It says here use the planning box below. Let me just scroll down to it. This is your planning box. You're going to add in any key terms you think would be relevant to your answer. You're going to tell us what the main steps and stages is and the cause and effect links. And once you've planned it out, it'll be so much easier to write it. Then step 3, we're going to write in clear paragraphs or bullet points. Personally, I recommend bullet points, but paragraphs is also fine as well. You're going to write about 4 to 6 points, depending on what kind of question it is. Make a statement and say why something happens. Then, step 4, use exam-ready language. This increases and decreases. As a result, this means that this leads to, we're going to avoid our vague phrases like, this helps, or this makes it better, this affects. You're going to make sure you're using key terms and scientific language. Some common 6-mark mistakes to avoid are listing facts without explaining, missing key terms, writing one long paragraph, going off topic, and not linking ideas together. So, follow this structure, plan it out, and avoid these mistakes. So, let's have a look. This is a example of a 6-mark question. As you can see, we've written in clear bullet points. We've explained cause and effect the whole way through. And just looking at it, it's very obvious what is going on. It's not a mess, it's not all one big paragraph, it's very obvious what's happening. Once you've written your answer like this, you're going to ask yourself these questions. Have you explained why things happen, should you need to? Have you used scientific vocab? Is your answer clearly structured? And did you answer the question fully? Create a checklist with these 4 questions, and as you write your answer, tick them off so that you know that you've done it. So, your turn. You're going to choose a 6-mark question from a past paper, and you're going to plan using the planning box above. So let me just go up to it, screenshot that now. 3, 2, 1, and you're going to write your answer, highlight your key terms, and check it against the mark scheme. Once you've done all that, you're going to use this checklist to make sure that you've done all of these things. So again, I'll give you a second to screenshot that. 3, 2, 1, and then rate how you feel about writing 6 markers. Again, I'll give you a second to screenshot the question as well. So 3, 2, 1, moving on. This is your reflection page. Here is where you're going to have a little think about how your revision is going. What are you doing well at the moment? And you can write some topics you're doing well. What things do you need to improve on? So again, write some more topics. Do you need to improve exam technique? Do you need to improve timing? Do you need to improve using keywords correctly? Write those down there, and then choose some of the things that you need to improve and write them as your goals for next revision session. Then you're going to choose one of these motivational statements to read out loud to yourself, or you're going to write your own motivation just to keep you really going, to stop you feeling bad about yourself, just to keep it happy. And then you're going to write some things you learned this week, and you're going to explain them to someone. That could be a parent, a friend, your dog, a teddy bear, the mirror. You're just going to try and explain it to someone so that it will really stick in your mind. Required practicals. This is, as I said before, when I said I'd come back to it. You scroll all the way up. So, more on them later. Now we're here. So, required practicals. This is the fun part. How are you going to turn your data into your answers? Well, for every required practical, you should be able to explain the aim, the variables, the method, your risk assessment, how to record results, and how to improve reliability and accuracy. What are the variables? Well, your 3 variables would be your IV, your DV, and your CV. It is very important that you know exactly what they are, what they stand for, and what they mean. So, IV, independent variable. That is what you change. It's deliberately changed by the researcher. So IV is what you change. DV is measured to see how it responds. So DV, what you measure. And the control variable, CV, are what you keep the same to prevent them from affecting the results. So again, IV, what you change, DV, what you measure, CV, what you keep the same. So have a go now. Find a required practical that you've done already and see if you can identify what you change, what you keep the same, and what you measure. And then over here we've got some tips. Reliability, you repeat and calculate your mean. To get better accuracy, you use better equipment. And to evaluate, you say a limitation and how you're going to improve. Also, when you're analysing your stuff, always include units. So again, we're going to choose one chemistry required practical, and you're going to complete the planner, which is on the next page, I'll show you in a second. Then you're going to answer exam question on it and highlight your key chemistry terms. Why does mastering practicals matter? Well, it helps you secure your easy marks. As I said before, your required practicals are where you want your guaranteed marks. It's also going to improve your scientific explanations, help you feel confident with the exam questions, and avoid practical mistakes. Required practicals are easy marks when you understand the aim, variables, and improvements. Here is your planner. I'm going to try and get it to fit on one page. I think 50. Yeah, there we go, 50. Name of practical, aim, variables, independent, dependent control, hypothesis, method, risk assessment, and how can you improve. What is a hypothesis? This is a question I ask a lot of my students, and a lot of them can't tell me, so I'm going to quickly run through it. A hypothesis is a prediction, so what do you think is going to happen? And then for your conclusion at the end, you're going to say whether your hypothesis was true. Alright, let me try and zoom back in again. Graphs. Drawing graphs accurately, you're going to use a sharp pencil, choose a sensible scale, label both axes with quantities and units, and plot points carefully and draw a line of best fit. A line of best fit is going to be a smooth line like this. It's not going to be all higgledy-piggledy, it's not going to try and hit every point, right? It's a smooth line that goes through most of the points on the graph. To describe a graph, you're going to state your trend, so does it increase or decrease? I'm going to use this one as an example. Yes, it increases. We're going to use some data value, so I would choose a data value there and a data value there, and say this one is this and this one is this, so that as you can see it's increased. You're going to include the units, so say this is time and this is temperature, this was done in minutes and this was done in degrees Celsius. I'm going to say that was 10 degrees Celsius at 10 seconds and it was 20 degrees Celsius at 20 seconds, for example. That's what we're going to do. Use your units. And you're going to avoid explaining why unless it's an explain question. Here is an example there. Just have a little read of that. Okay, to use data correctly, we need to quote specific numbers from the graph or table. Again, always include your units and use words like increase, decrease, constant, and plateau. What does plateau mean? Do you know? Well, let me try and draw. Let's say this is our graph and it steadily increases like this and then it flattens out like that. This point here where it flattens out, that's your plateau. Let's get rid of that now. Alright. Don't use language like goes up or goes down. You're going to be scientific. And we're also not going to forget the units. We're going to describe the data, not the method. We're going to explain the trend only when asked. So when only a description is needed, we're not going to explain the trend. And we're also not going to ignore an anomaly. Just so you know what an anomaly is, have a little quick read of that. I'll give you a couple seconds. And let's carry on. So now here's your final reflection. What did you study today? How do you feel about practicals? How do you feel about graphs? What went well today? What needs work today? Some goals for next time and some confidence boosters. Go and reward yourself. You deserve it. And finally, before we end the video today, this is a method for writing notes per topic. So all your key terms per topic, everything that you remember in the topic, just scribble it down, give yourself 5 minutes and scribble everything that you can remember, and then once the 5 minutes is up, go to the textbook and anything that you missed, put it in that box there. Again, I'll give you a couple seconds to screenshot. 3, 2, 1, and congratulations for completing, and thank you so much for watching. As always, like and subscribe. Love you guys. Have a great day. Bye.